I'm Austin Garber, and this is my final project for ENGI-305 about data mining. So before we get into it, I split the project up into 3 phases, like was outlined on Blackboard, and the project rubric that had all the requirements together differs a little bit from each individual submission. So I am going to record one long video and then indicate where each piece of the PO1, PO2, and PO3 are covered in it. So the first question, what is data mining? These are a couple definitions from various journal articles that I got. The search for valuable information in large amounts of data, and the process of discovering patterns in large data sets. In layman's term, what it is taking, there's all kinds of data out there. And the potential to turn that data into information, which can be used in a business process or, for other purposes. So basically, what data mining is looking at large sets of data and trying to pull information or pull useful data out of it. So these are some primary data mining techniques. I guess I'll just read through them. Classification, which is what we're going to be using, which is what I use for my data analysis in this project. Regression, which I explored a little bit in MATLAB. Clustering, which I also explore a little bit in MATLAB. Association rule, or dependency modeling, which describes relationships between variables, which again we'll look at in MATLAB. Anomaly detection, which is the discovery of significant changes in data from previous or normal values. And summarization, which is taking all the data that you've collected and coming up with a compact way to describe a very large data set. So a few industrial engineering concepts that can be applied to data mining. Obviously, machine learning, and one of the most important parts of machine learning is the development of neural networks. Heuristics and search algorithms, which I actually will be doing an additional assignment and looking at the impact that this project, the information that I've gathered in this project, how that can apply to the traveling salesman problem and the genetic algorithm. Forecasting, which is kind of the point of gathering information. You want to do whatever you can to get the best prediction of what's going to happen in the future. That's kind of the point of data mining. Statistical analysis through ANOVA and chi-squared. Correlation and regression analysis. And ultimately, the point of data mining is to make decisions based on the information that you've gained from it. So decision analysis falls in that category too. So there's a lot of different ways that you can apply data mining to business. So I kind of looked at, I tried to put together a list of them and maybe go through and explain how each one is directly applicable. Risk analysis is pretty self-explanatory. Companies want to know, for example, in the data set that I'll be using later in the project, companies will want to know how likely they are to have to fork over money if somebody makes a claim against them. In my case, it's the TSA. If somebody makes a financial claim against the TSA, what are the odds that the TSA is going to have to pay out for that? Root cause. Actually, I'm not going to go through and read the rest of these. I suppose you can pause it and take a look at them. So the 3 paradigms that I'm going to be talking about are the classification learner, neural network clustering, and curve fitting, which is, as I said previously, classification, clustering, and regression are the overarching concepts that each one of these tools can address. So the MATLAB classification learner is used to identify clusters and patterns in large data sets, and it utilizes a variety of modeling methods to classify the data. As you can see, this is a screenshot of just the different types of model that you can build. Some of these are easy, some of these are non-computationally intensive, some of them are very computationally intensive, and a little bit of knowledge about what your data looks like will go a long way in deciding what's worth it to run and what's not worth it to run. And I'll talk more about this when I get to the actual data analysis part. So this is a screenshot of the classification learner, and as you can see on the left here, you MATLAB can run through and build models based on different criteria. So you have relationship trees, KNN. There's also a little bit lower, you can't really see it now, but there's a Gaussian model and a linear model. And then it rates the accuracy of those models. So basically, you're going to pull the most accurate model to use to predict your future data. A confusion matrix is kind of an indicator of how well the model was actually fit. So this is an example problem. This is the relationship between 4 different flower attributes and their classification as flowers. No, I take that back. This is an ovarian cancer data set. So based on the measurements, 1 through, I believe there's 50 different measurements, actually 100 measurements. Based on 100 measurements, how likely is it that a person will be diagnosed with, or a person will have ovarian cancer? And so what the confusion matrix does is let you know how many times you're running into type 1 or type 2 errors. So a high percent on the diagonal, or the eigenvalue, is close to 1, is more accurate modeling, and you'll see fewer type 1 and type 2 errors, and a low percentage on the diagonal. Or, it's kind of hard to see in this one because it's only a 2 by 2, but if you expand it, you'll get blocks of high percentages off the diagonals every once in a while, and that indicates greater amounts of type 1 and type 2 errors. The ROC curve is going to indicate the number of type 1 and type 2 errors in the trained model versus the data set. So as basically you look at this is another indicator of how accurately the model's been classified. You're looking for the area under the curve to be as close to 1 as you can get it, and for the graph to look as much like a right angle as possible. The second app in MATLAB that we're going to talk about is the neural network clustering app. And what this does is it generates a variety of self-organizing maps that indicate the strength and relationship between clusters of attributes of the data and display those relationships in a way that visually represents potential patterns. So you're going to have, there's three parts to building this neural network. Your input attributes, so you just have lists of, let's see, in this case it looks like 4. This is the flowers example. So you have 4 attributes, and then we're going to run it through a 10 by 10 collection of neurons. And each one of those neurons is going to be made up of a combination of the input variable. And then what we'll end up with is something that looks like this. Each one of those blue hexagons represents a collection of attributes, and we are going to look at the relationship between them. So again, each one of the blue hexagons represents a cluster of attributes, and you can kind of see a rift down the left side of this. And what that indicates is that there's a gap between the variables in that part of the map. So the hexagons that have light colors connecting them are very similar. They resulted in accurate representation or guessing of what kind of flower it was. And where the colors are darker, there's little or no relationship between, say, this neuron and this neuron. And a weight positions map is just another graph that the neural network lets you output. I thought it was interesting. It kind of looks like a traveling salesman problem. I'm not sure if I'll be able to apply that or not, but this is just another way to represent the relationship between the neurons. Longer distances indicate dissimilarities between the attribute clusters. And then the last one that I'll look at is the curve fitting app. And so this is actually my data, the TSA claim data, and I tried to fit it with a Gaussian regression. And as you can see, my R² value is not very good, so this doesn't really represent my data very well. And actually, it looks like I've got a couple outliers that are really skewing my data, so if I wanted to accurately describe that, I would probably go in and remove those outliers, and then see if maybe I could fit my model a little more accurately. So the curve fitting model or app uses a variety of types of equations: exponential, linear, Gaussian, polynomial, power, Fourier, Weibull, and there's a couple other ones too. It is beneficial to know, what the mathematics are behind each one of those distributions, because that'll help you when you're deciding. You'll spend less time playing with it and more time getting to the model that's actually close to your data points. And so as you can see in this Gaussian model, MATLAB generated coefficients that represent my data as closely as possible and generate an R-square value to indicate how closely my curve fitting models the actual data. And I did a decent amount of research in journals and stuff like that, so this is just my list of references. Thanks. Okay, so on to phase 2 of the project, where we actually start talking about the specific data that I used and how I used it and what it was used for. So my problem description, I gathered TSA claim data, which you hope will be used by the TSA management as well as airlines and airports to identify factors that contribute to incidents in an attempt to reduce monetary loss from an airline and an airport perspective, and to identify potential threat factors from a TSA perspective. And I guess I'll go a little more in depth and that'll make a little more sense in a minute. So the scope, we're going to look at a very large data set of TSA claims from 2002 to 2006. It's unfortunate that I wasn't able to get more recent data. So I guess an assumption that we can make is that this data was presented at the conclusion of the time period. Otherwise, we need to retrain our models and everything with more up-to-date data. Here's a screenshot of the data set. I had to manually discretize the data to make calculations in MATLAB simpler, and I'll explain what that means and how I did it once I get to the actual live presentation. There are 97,232 claims from 2000 to 2006, and this information includes claim number, claim date, incident date, airport, airline, claim type, claim site, item, claim status, claim amount, close amount, and disposition. So the goal of this project is to identify which attributes contribute the most significantly to the value and outcome of a TSA claim. So we're going to do this through MATLAB's classification learner. And this is just a brief concept map. We had our bulk claim data. We input it into Excel, normalized the data, then exported that normalized data into MATLAB, and built our model using the classification learner to output an equation that we can use to predict, based on different attributes like airport, claim amount, that sort of thing, how much the close amount will actually be for the TSA. And I also built another model that will predict the disposition, which is whether or not the TSA is going to have to pay out for that claim in a separate model. So I actually built 2 models off of this. Some of the constraints that I had were processing power. I tried to train all 100,000 data points at once, and it would run for an hour and slow my computer down, and then MATLAB would say I can't process that much data right now. And another constraint would be that the data is not as up-to-date as I would like it to be. So talking about the classification learner again, I guess I just said this. That little error says that the data exceeds the maximum array size preference. It was slowing my computer way down, so I had to do it in chunks and use pieces of the data. Basically, I shrunk it down into a representative cross-section to use. So this is the first model, is the prediction of the close amount. After inputting all the information into the classification learner, we found that the accuracy of the model was relatively low at about 60%. And so I'll go back in and explore what that means a little later. This is the second model that I trained, predicting the disposition, whether or not the TSA is going to have to pay out for a claim. And this one is actually a little bit less accurate than the first one. And so, as I was talking about earlier in the video, you can see that this 248 off the diagonal is actually higher than the 245 and 133 on the diagonal. And so this indicates variation from it indicates that the model is a little less accurate than maybe we would like it to be. So this is these are the results of the classification learner. At the top of the screen there are all of the variables that you can adjust, and so each number here represents a different airline, and I have a list of those airlines and airports and claim types and items and stuff like that stored separately, so you can take a look at that. And so one thing that I thought was kind of interesting is based on the trained data, it seems like the TSA rarely ever will pay out more than $350 to their claims. So the close amount will rarely be more than $350. So as you can see, and you can go through and play with this as well, increasing the claim amount more often than not, at least from what I explored. I'm sure there's combinations that'll give me something else, but raising the claim amount will cap it out at $350, just because that, according to the data, it's very, very rare that the TSA will ever pay out more than that. And so this is the second model, using the disposition. So 1s indicate that the claim will be paid, 3s indicate that the claim will not be paid, or the claim will be denied. And so you can see that variable 4 right here has a very large claim amount. I believe it's $1 million. And I found that as that number, there's a threshold that you hit where, based on the data that we trained into the classifier, you're more than likely going to get denied that claim. The claim amount's it seems to be a good indicator of whether or not the claim will be substantiated. So despite the data size limitations, MATLAB is able to predict close amounts of TSA claim data based on 7 inputs, and the disposition, or the result of the claim, based on 6 input variables. And this is a design that the TSA, airports, and airlines can use to predict the claim values and the dispositions of it, so they can kind of forecast, how much they're going to be paying out in a certain period of time. And another cool thing is that you can constantly update this and retrain the data. And by retraining the data, you can keep your model up to date. So you drop off old data and simultaneously update with new data, and then retrain your model, and then your classifier will kind of learn with the new data that's input. And like I said briefly, I added a way to test the claim amount model, which is leaving the disposition value in the variables. And so if you adjust that to 3, that means that the claim was denied, and my model will correctly predict that the close amount will be 0. And I mean, this seems pretty obvious, but it's a way. I mean, I didn't add that in. The classification learner noticed that pattern on its own. And a way to test the disposition model, like I said earlier, is to adjust the claim amount to a very high value, and the model will predict that since the majority of high claim values are denied, the disposition will be 3 if the claim amount gets to a high value. All right, lastly is phase 3, which we'll be talking about the global implications of data mining. Since this is a relatively new thing, as computer processing power has ramped up over the last 15 years, a lot of cool discoveries can be made through the analysis of big sets of data that we couldn't make in the past. So quickly, I wanted to describe what big data is. It's extremely large data sets that may be analyzed computationally to reveal patterns, trends, and associations, especially relating to human behavior and interactions, which is something that I find really interesting. For example, what is a neural network? A neural network attempts to mimic the decision-making process that goes on in the human brain. You build this array of neurons that are sending signals back and forth, and so it's kind of cool to think about. It's kind of the crux of artificial intelligence, and the development toward that is really cool. So we haven't had the technology to attempt to understand macro human interactions on the basis of micro interactions. And what I mean by that is we can't take what goes on in one person's head and expand that to predict what society is going to, like the trends in society. And the utilization of data mining and stuff like a neural network can let you build relationships out of that you had no hope of developing before. So an example, analyzing 10 million tweets to gather information on the depression level of society so that we can, from like a pharmaceutical company standpoint, we can predict how much antidepressant to produce for, the upcoming year. And there's all kinds of applications like that. That's just one. And interestingly enough, we can use data mining techniques to discover up-and-coming topics to be explored by data mining, which, it's not really, not all that relevant. It's just kind of a fun fact. So briefly talking about human psychology and data mining, I mentioned briefly in the last slide that there is a similarity between the human brain and neural networks. Neural networks are designed to mimic the interactions that happen between neurons in the human brain. And I guess I also said this in the last slide, that data mining is kind of at the crux of the development of artificial intelligence. Being able to collect very, very large amounts of data and pull valuable information out of them is critical to the development of artificial intelligence. And you can see a good example of that is that Jeopardy playing robot, Watson. It applied a variety of data mining techniques to guess the answers to Jeopardy questions. And so, combined with an increasing computational capability and the increased knowledge of heuristic and search methods, decision analysis that approaches the level of the human brain may not be far off. And I'm sure that this is up for debate, whether or not we're actually close enough to artificial intelligence, or where we'll actually get to the level where you can consider it artificial intelligence, is debated. So this is a data mining course that I put together. The course rationale would be to develop the technical and analytical skills to approach unexplored data and extract pertinent information. So I would break this course up into 4 different sections. The first section would be data types, manipulation, normalization, and sorting. And what this would be explanations of what different types of data are and how they can be manipulated and normalized to the point where they can be analyzed. And so the kind of coursework that would go along with this would be terms and basic concepts and homework, and the presentation of jumbled data, and then we would ask the students to sort that data based on certain specifications. The second topic would be data acquisition, and what this would be an overview of database systems and queries, as well as a study of APIs. And the coursework for that would be a project to find an unmanipulated data set from an API or from a database, and then collect the data and apply the concepts from the first section to the data, and normalize it to the point where it can be analyzed. The third section of the course would be statistics, and in this section we would review the basic statistical concepts, followed by advanced statistical data analysis. That would cover things like regression, ANOVA, and forecasting methodologies. So the homework for this session would be terms and basic concepts to get the students familiar with it, and then the project would be to continue with the previous data set and apply the statistical manipulation. So the kind of overarching theme of this course is going to be to start from nothing, like force the students to go out and find data, and then apply all of the steps throughout the class, work with the same set of data for the entire class. And then the last section would be a machine learning section. And what this would be the programmatical basics of machine learning and heuristic methods and their applications. And what this would include is the mathematics behind it, stuff like Gaussian regression, genetic algorithm, simulated annealing, that sort of thing. And then the coursework for this section would be homeworks. The homeworks would be terms and basic concepts. The project would be to continue with the previous data set, like I was saying before, and apply machine learning methodologies for further analysis. And then I could see this class being an upper level course, and then have the final be to present the semester's worth of project development and to write a journal paper. So ideally we want each of the students to be working on the same data set for 14 weeks or something like that throughout the semester, so that they are comfortable with it. And the goal would be to have the students discover things that have yet to be discovered, which is something that's really cool, and it gives it would give each student an opportunity to actually get a journal paper published. Because if you actually discover a new trend, or if you discover information that hasn't been documented, then there is a good chance that you can get a journal published. So now I'm going to go over to my actual project and start talking about how I manipulated the data to import it into MATLAB and how to run the classification learner, and then the results that I got from running that experiment. All right, so this is the bulk data imported into Excel, and as you can see, there is a lot of it. So what I did is I went through and pulled out the important factors, which I decided were the airport, the claim type, the airline name. This is the item. It's missing a header, but the item is there. The disposition and the claim site. And then what I did is I used a VLOOKUP function to pair each one of these with a number to indicate which it is. And the reason that I did this is because it makes it easier to analyze the data in MATLAB if it's all numeric. So this is the data that was imported into the MATLAB, and so you can see that the airports were converted to a number indicating which airport was which. So we can look at the first one and see that there's a 6, and then scroll over here and match up the airport code with 6 and see that that was the MCO airport. And I just did that to make it easier to analyze the data in MATLAB. And I kept all 97,232 inputs. And I guess I will see you over in MATLAB now. So this is the data imported into the classification learner. So we're going to select the small data set since my computer can't handle a large one. And we'll go ahead and train the disposition model. So we're going to select disposition as our response, and we'll go ahead and get rid of close amount in this case. One interesting thing that I had to overcome was that MATLAB looks for discrete responses, so you can't import continuous data and run the classification learner on it for whatever reason that is. So then we'll go ahead and hit start and see what the model builds. Okay, so here we have the classification learner running, and it starts out by not building any of the models. You have to decide what models you're going to build in. So you can see right here, these are predictors: airline, airport, claim amount, claim type, item, and location. And if you're interested in looking at the relationships between any of the variables, you can look at that if you want to. But so what we're going to do is we're going to hit all quick to train models just to make this quick, and then hit train. And so as you can see, MATLAB has selected the models that are the quickest to run, and it has gone through and run each one of the model types, and has determined that the best model is a medium decision tree model. The graphs in here indicate which points fall outside the model and which points are accurately predicted by the model. So we can go over to the confusion matrix if it's going to let me load it. Yeah. So here we have another indicator of how well the models fit. This is similar to the, and granted, each model is not going to be exactly the same as you go through successive iterations. But you can see that certain parts of the model are fit fairly accurately, and certain parts of the model are fit very poorly. As you can see, this section of the model has a 82% false negative rate, which is not very good. The ROC curve, if it will load. So here we have the ROC curve for the disposition model, and compared to the last one, you can see again that it's not not nearly as accurate as the model that was shown in the PowerPoint. Again, you're trying to maximize the area under the curve. That should be as close to 1 as possible, and this angle should be as close to a right angle as possible to indicate an accurate model. So then what you do is you go through and you export the model. All right, so here I have the results of the network that I built. and my recorder's kind of funky, so I'll probably have to be jumping back and forth to show you what exactly this is. So if we take this is the disposition, so we can take our test table for the disposition, and just go through and adjust these variables for each one of our predictions, to see what kind of results we'll get. Item, how about the 10? Location, we'll change that to 2. So we adjusted this first line, and you're going to run back down here. And it looks like I have it in the script, so I'm going to hop over to that real quick. You won't be able to see me run the script, but you should see it pop up on the screen. So that's the claim amount. So let's predict the disposition. And we'll evaluate the selection. Okay, so there you can see that just adjusting those parameters predicted that the disposition of these new levels of the attributes, new variables, will result in a 2 for the disposition, which I believe is an adjusted payout. So the TSA will close at a lower value than what the claim amount is. I believe that's how that works. So all right, so now I'm going to jump over and run the claim amount, or the close amount predictor. So, and again, I apologize that you can't see this. So there you go. For these same variables, and that makes sense actually. So we've got the claim amount being 400, and the close amount is going to be 300. So the two networks do end up lining up and accurately predicting. One interesting thing you can see is this one right here. This is a $1 million claim that actually got closed at, sorry, hold on. I forgot to open up my other test table. Okay, that's better. So scratch what I was just saying. These are the values that were predicted these values. So like I was saying in the presentation, if we go in there and change this to a 3, and then rerun our predicted close, you can see that, the TSA is not going to pay anything out if the claim was denied, and that was an interesting, it was an interesting relationship, not in and of itself, but to discover that MATLAB was able to create that relationship without my input. And so here I'll just scroll up a little bit and let you see the command in MATLAB. And so our predicted close, this is our model that we built, and I'll show you how that works in a second. And then you input your test table that matches the trained model. The variables match the trained model. And because I had to discretize the data, my points actually start at 1/10th, 1/100th. And so I subtracted that 1/100th and then normalized it back to the actual value. So this does represent $350. This does represent $5. Here's our disposition function. It's a different trained model and a different table input. Since there's a difference in one variable, the disposition isn't used to predict the disposition, because that would be kind of silly. That's all I have for my project. Thanks for watching.